Welcome back. In this video, we're going to go over section 2.4, which kind of sums up some things we've done over the last few sections, and we'll take a look at a general strategy to solve linear equations in one variable. So we're going to take a look at the steps, and then we'll try some examples. So the first thing to do is to simplify each side separately as much as possible. So this would include applying the distributive property to remove parentheses and combining like terms. Once you can no longer do anything else to the left side, right side separately, it's time to move on to step 2. Step 2 will collect terms with a variable on one side of the equation. So we'll use the addition property to collect the terms with the x or whatever the variable is on either the left or right side. But the key thing is to get all the variable terms on one side. And then in step 3, we'll collect all the constant terms on the other side. That is, whatever side you've picked for the variable, the constants all go on the other side. Then we'll, in number 4, use the multiplication property of equality to make it so that the coefficient of the variable is a 1. And we'll see by example how that's done. And then finally, under step 5, it's a good idea to check the solution to make sure we didn't make some little mistake along the way. Okay, so let's try. First of all, we have the equation 5 times, in parentheses, x plus 3 equals 35. We're going to simplify each separately. The right side is just a 35, so there's nothing to be done there. However, on the left side, we can distribute the 5 to remove parentheses. Okay, we'll get 5x plus 15 equals 35. So then in step 2, collect terms with the variable on one side of the equation. So right now, there's only one term that has a variable, and that's the 5x. It's already on the left side. So step 3, collect constant terms on the other side. So that means that that 15 that is on the left side of the equation shouldn't be there. And so we're going to take and subtract 15 from both sides, so that we'll have 5x on the left side and then 20 on the right side. Okay, so now it says use the multiplication property of equality to make the coefficient of the variable be equal to 1. So right now the coefficient of the variable is at 5, so we need to think about what we can multiply both sides by or divide by to make it so the coefficient of the x is a 1. So if the x has been multiplied by 5, it makes sense that we can divide by 5. So we'll divide both sides by 5 to get x before. Okay, and that will do it. Our solution is 4. The check part I will leave to you. So you replace the x by a 4, and then we'll make sure that the equation checks out. That is, we get a true statement on in the end. Okay, so let's move on to our next example. For this one, we have minus, and then the quantity y plus 9 equals 8. So here, again, we'll distribute to remove the parentheses. So let me out for the minus sign there. Minus y minus 9 equals 8. So here the variable is already on the left side. So we want this negative 9 that is here. We need to get rid of that. So to get rid of that, we're going to add 9 on both sides. So this will leave us with minus y on the left side and then 17 on the right. So now the coefficient of the y is a negative 1. So we could either multiply or divide by negative 1. Make it so that the y is alone on the left, and we've just got negative 17. So our solution here is negative 17. Okay, again, I'll leave the check to you. All right, so let's try this one. At this point, maybe you would like to pause the video, try the steps on this one, and then restart the video and see how you did. Okay, so now I'm going to begin by simplifying the left side. I'm going to distribute to remove the parentheses. And there's no more parentheses, so I'll combine like terms on the left side. We'll have 2c minus 5 equals negative 1. So now our equation just has 3 terms in it. 1 has the variable and 2 don't. And the variable term is already on the left, so I'm going to keep the left side for variables, and then that means that the negative 5 that is there, we need to get rid of that by adding 5 on both sides. We've got 2c minus 5 plus 5, which is just 2c, and the right side is just a 4. Okay, then we can divide both sides by 2, getting c as 4. Okay, so 2. C is 2. Sorry, I'd forgotten to do the division by 2. Okay, so c is 2. All right, so that will do it for this one. Our solution is 2. And just for fun, this time I will go ahead and do the check. Some of your math professors or teachers require a check, others do not, but it's always a good idea. The only downside to doing a check is if you make a mistake on the check, but maybe your answer was right in the first place, then that can make you incorrectly figure that you were wrong, right? So you got to be careful with the check too. Okay, so here I've replaced the C by the 2 that I think is the solution, and we're going to calculate and see if we get a true statement or a false statement. And it looks like we're going to get a true statement. So that verifies our solution is 2. Or I've made 2 offsetting mistakes, but I think that we're right. Okay, all right, so let's go on to see some more examples. So in the next one, we see that we've got a fraction in it, but that's okay. We're going to distribute here to remove that fraction. So since this is our first one with a fraction in it, let me show a little more steps on the distributive property. Either way, we're multiplying both terms inside the parentheses by that 2/3. And then here, nothing is going to happen on the right side for now. 2/3 times 9 is going to be 6, so we'll have 6a. And then 2/3 of 12 is going to be 8. So we'll have 6a minus 8, and that makes 8 plus 2a. All right, so in this one, in contrast to the other examples that we've done, we now have variables on both sides and constants on both sides. So at this point, you have to ask yourself, well, which side would I like the variable to be on? And it doesn't really make a difference. It's totally up to you. As you know, the properties of equality, you can add, subtract, multiply, and divide as long as it's not 0. Both sides by the same number. And so as long as you're playing by those rules, you will be okay. So most people like to collect the variable on the left, so that's what I'm going to do. So I'll take and make a little space on both sides. If we've decided that the variable is going to be on the left, then that means that this 2a that you see on the right has to go away. So we'll be subtracting 2a from both sides. Now on the left side, 6a minus 2a, we're sorry about that, Zoom crashed on me again. So we've combined like terms on the left side that gave us 4a minus 8, and then on the right side, just a single 8. Okay, so now we've committed to having the variables be on the left, so that means that the minus 8 that is in the back needs to be dealt with, right? So we're going to add 8 to both sides to make it so that we have just 4a on the left and 16 on the right. Once you've done that, you can divide both sides by 4 to get 4 for a solution. All right. In the next one, we'll see that we have some parentheses in here that we'll need to distribute to remove those. Pause video, take a minute to try this one, and then restart the video and see how you did. Okay, so our first step here is going to be to distribute this -3 into the parentheses. Remember order of operations, we need to follow order of operations. So if you first looked at this and go 9, okay, then you're not quite there yet. We do have 12 minus 3, but the 3 is multiplied by the stuff in parentheses first. You know, multiplication comes before subtraction. So we'll have 12 minus 12x. The 3 times 4x there gives us that -12x. And then -3 times 3 gives -9. Okay, so we'll have 12 minus 12x minus 9 equals -17. Combining terms on the left side, the 12 minus 9 is 3. So we have -12x plus 3. That's equal to -17. Then we're going to subtract 3 from both sides. That will give us -12x is -20. And then if we divide both sides by the -12, that will give us 20 over 12. And that's 4 times 5, 4 times 3. That will be 5/3, our fractional answer, but that's okay. Okay, good. In the next one, there's a lot to do, but don't be put off by that. We'll just take each step, one step at a time. So we're going to simplify the left side as much as we can. We'll simplify the right side as much as we can, and then go from there. So taking a look just at the left side, don't be intimidated by any of this, even though it's longer. Just take a look at the left and forget the right for a second. So we have 6y minus 18. We distribute to remove parentheses. And then minus the 7, just coming along for the ride, our equal sign, and then distributing the 5 on the right side, we have 5 times 4y, that will give us 20y, and then 5 times 3 is 15, and then we'll just copy over that negative 12. All right, so we've done one thing. We've got the parentheses all gone, so now we'll combine like terms. 6y minus 18 minus 7 is minus 25. If you find working with those negative numbers challenging, make sure to review that, because as you can see, it's just one little part of that solving equations process. So if you're stuck for 5 minutes trying to figure out negative 18 minus 7, then it's going to really slow you down. So make sure to practice working with negative numbers. Okay, right side, we've got 20y plus 15 minus 12. 15 minus 12 is going to be 3. All right, so once again, we have two variables, terms with variables, two that don't. We have 4 terms altogether. We have to decide which side we'd like to collect the variables on. Earlier, I'd said that usually people like to collect the variables on the left side, but if you take a look here, if we do subtract 20y from both sides, our left side will have a negative 14y. And sometimes people like to avoid having negative numbers. And so if that's you, you might like to subtract 6y from both sides. So we're going to do that this time, even though it's going to make it so that our variable is on the right. So we're going to subtract 6y on the left. We're going to subtract 6y on the right. This gives us just on the left negative 25. And then the right side will have positive 14y plus 3. Okay, so now we're committing to sticking the variables on the right side. So the left side will be constants. So then we need to subtract that 3 from both sides. We'll have negative 25 minus 3 equals 14y plus 3 minus 3. The left side now is negative 28. The right side's 14y. Okay, we are almost there. If we have negative 28 is equal to 14y, we're going to need to divide both sides by 14 to get the y alone. We'll have negative 2 equals y. So negative 2 is our solution. Okay, again, the check there is left to you. All right, so this is our last example for this page, I think. So here we've got parentheses, we've got square brackets on the left side. When you see an expression like the left side here that has both parentheses and square brackets, this is typically done just to make it visually easier to read, so you don't have a whole bunch of nested sets of parentheses. In terms of the meaning, though, here, the meaning is the same. It's just serving as a grouping symbol. We're going to start on the inside and work our way outward. So I've got 6 times and then 4 minus. Negative 2 times 7y is going to be negative 14y. And negative 2 times negative 1 will give us positive 2. That all stays inside those square brackets. Okay, then outside we have 8, and then that's multiplied by 13 minus 8y. 8 times 13 is 104. 100, and then 8 times negative 8y is negative 64y. 4 doesn't look so good. Okay, all right, so now on the left side, inside the brackets, I can combine a little bit. 4 plus 2 gives 6, so we have negative 14y plus 6. And then on the right side, I have nothing to do. I'm going to rearrange it just so that I have the negative 64y in the front. For some reason, I like seeing the variables first and the constants after. That's my personal choice. Okay, so now on the left side, now we're distributing this 6. 6 times 14 is 84. So that's going to be negative 84y plus 36. And then the parentheses finally are gone. The right side, nothing happens this time. Okay, so once again, we've gotten it down to where we have 4 terms, 2 with variables, 2 without. The left side has a variable term and a constant term. The right side has a variable term and a constant term. So I'm going to collect the variables on the left, just because I chose that. Okay, it could have gone the other way if you want. So we'll have negative 84y plus 36, a little space. So I'm going to add something here in a second. In order to get rid of this negative 64y, we're going to have to add 64y on both sides. Okay, so the left side, negative 84y plus 64y is negative 20y. We'll still have the plus 36. The right side, the negative 64y and plus 64y are going to add up to 0 y's, so we'll just have 104. Okay, almost out of space. I better finish soon. So here we've got negative 20y. We're going to subtract the 36 from both sides. So this will be 104 minus 36. Let me do my subtraction. So 14 minus 6 is 8. 9 minus 3 is 6. Looks like 68. Negative 20y is equal to 68. And then dividing by negative 20, we'll have y equals negative 68 over 20. And if I divide out that common factor of 2, we'll have negative 34 tenths. Better than that, that will be negative 17 over 5, it looks like. Okay, so that takes us to that end of that example. That was a little involved, but we're able to do it, I think. So we distributed to remove parentheses, combined like terms, distributed again, collected variable terms on the left side, even though we ended up with a negative coefficient, and that's okay. Done with that one. So let's try a little more. In the next one, we'll see that we've got some decimals in there, but we can proceed in the same basic way. We're going to distribute to remove the parentheses and combine like terms as usual. So here we have 0.55 times 100n. That will give us 55n. And then 8 times 0.55 is 4.4. And then on the right side, we'll have 6 times 85, 0.6 times 85n. So let me do that. So that's 51n. And then 0.6 times 114, that's 60, 84, 8.4. Okay, so that takes care of the parentheses. So now we're going to collect variables on the left. I'm going to subtract 51n from both sides. That will leave us with 4n plus 4.4. And then on the right side, we'll have 8.4. Next, we're going to subtract the 4.4 from both sides. That will leave us with 4n is equal to 4, so that n is equal to 1. Okay, so here I've skipped a couple of steps and I've sped up a little bit. If that is too much for you, send me an email and let me know if you have any questions on that. Okay. The last piece of this section has to do with classifying equations. So depending on the nature of the equation we may have, we can have one solution, as we've done so far, or depending on the equation, we may have no solutions or infinitely many solutions, and there's special words just for that. So a conditional equation is the kind of equation we've dealt with so far, where it's true for one or possibly more values of the variable, depending on what type of equation we have. As it turns out in this chapter, we're going to have just one value of the variable where there is a solution and not infinitely many. So just one. And it's false for all others. An example of a conditional equation, an easy one, is all the ones we've seen so far, or something like x plus 2 equals 10. Okay, nice easy equation. That's true if x is 8, and false every other time. Okay, that's an example of a conditional equation. An identity is an equation that's true for any value of the variable. So an example of an identity would be x plus x equals 2x. Okay, so if you look at that and say, well, you just kind of simplified the left side, so what? Yes, that's true. If I asked you which x's would make that true, hopefully you would say, well, that's true no matter what x is. That's true for any value of the variable. You can try replacing x with any number you want, and you should see that no matter what you get something true. A contradiction is kind of the opposite of that. No matter what happens, you're going to get false. Okay, an easy example of that would be to say x is equal to x plus 1. So what number is equal to 1 more than its own self? There's no such number equal to 1 more than itself. So that's a contradiction. Contradictions are never true. Identities are always true. And conditional equations is conditional. Sometimes yes, sometimes no. Okay. So then what we want to do in the next couple of examples is go through the solving process that we've practiced, and then also tell whether the equation that we arrive at is a conditional equation, an identity, or a contradiction. Okay, so here we're going to start by distributing to remove parentheses. So in here, of course, you're not going to say 13, right? You're going to distribute the 9. We'll have 4 plus 9 times 3x is 27x. And then 9 times 7 is 63. Our equal sign, take a little break. Okay, on the right side, we have negative 42x minus 13. And then 23 times 3x is 69x. 23 times negative 2 is negative 46. Okay, take a little break again. So now we can forget the line that came above and just focus on the next one. Combining like terms, 4 plus negative 63 is negative 59. Sorry, my pen just stopped. Give me a second. All right, so let's try that again. So on the left side, we have 27x, and then the 4 minus 63 gives us negative 59. Okay, on the right side, I have a couple of terms with x's and a couple that don't. Let me take the x's first. Negative 42 plus 69, that'll be 69 minus 42. And that's going to give us 27 x's. That looks familiar. And then negative 13 minus 46 is going to be 59, right? 46 plus 13 is 59. Okay, so we ended up with negative. We ended up with, on the right side, 27x minus 59. So the left side and right side are equal to each other. They're like look the same as well as being equal. So if we were to continue applying steps here, maybe you'd say, okay, let's add 59 to both sides. You get 27x equals 27x, and then subtract 27x from both sides, you would get 0 equals 0, if you like. You don't have to do all these steps. As soon as you get to here and see that, well, the left side and right side just look equal to each other, you can stop right there and just say that this thing is an identity. Okay, you could say the equation is an identity, and if you want to tell what the solutions are, you could say all real numbers. Okay, and that'll do it. Okay, let's try the next one. We're going to begin again by distributing to remove the parentheses. Okay, so I've got 11y. 33 minus 5 equals 19. So now combining terms on the left side, we have 11y. 33 minus 5 is 28. That's equal to 19. We're going to subtract 28 from both sides. So on the left side, we'll just have 11y. And then 19 minus 28 is going to be negative 9. Okay, and then once you divide by the 11, you should get negative 9 elevenths. So our solution is negative 9 elevenths, and this is a conditional equation. The equation is true if you replace x by negative 9/11, and it will be false otherwise. Okay, so next, let's try this one. As before, we're going to distribute to remove parentheses, then we'll combine like terms and go from there. So you may want to pause the video, try this one yourself, and then restart the video and see how you did. Okay, so I'm starting here by recopying the 12y, then distributing the 5. 5 times 5 gives 25. 5 times 3y is 15y. Then the right side, distributing the 3. 3 times 9y is 27y. 3 times negative 4 gives negative 12. Combining like terms on the left, we'll have 27y plus 25. And the right side, we have 27y minus 12. Okay, so now taking a look at it, you can either recognize that something's wrong, or if you continue, we could subtract the 27y from both sides. I said 27, so I wrote it 25 here. 27y plus 25, 27y minus 12. If we subtract the 27y from both sides, then we're left with 25 on the left side and negative 12 on the right side. And that's false, right? 25 is not the same as negative 12. Since that's always false, it means that there's no solution. And the equation is a contradiction. For no solution, you can either write out the words no solution. Sometimes you're asked to write the empty set, which is a set of curly braces with nothing in between, or sometimes the symbol for the empty set, which looks a little like a fat zero with a slash through it. All of those are ways of indicating that there's no solution, and then we would describe the equation as a contradiction. All right, so that takes care of this section. Just to kind of sum up what we did. The general strategy we saw was to simplify the left and right side of each equation as much as we can, distributing to remove parentheses, combining like terms, and then collecting all the variables on one side, the constants on the other, and then using the multiplication property to make it so the coefficient of the variable is 1, and then finally doing a check. And then we saw some examples, and then we talked about how a conditional equation is sometimes true, a contradiction is never true, and an identity is always true. And that takes us to the end of section 2.4. Let me know if you have any questions, and have a great day.